the time to our first speakers, Dr. Xiaoyu. He is an entrepreneur, academicus, and an electrical engineer. He is currently a postdoctoral researcher in the departments of mechanical engineering, City University of Hong Kong, and co-founders of Suzhou CX technology companies. He has led the developments for over 20 commercialized hydrogen energy products and also participated in the formulations of multiple hydrogen energy related group standards. His research interests include resilience, controls of sustainability energy system and hydrogen-based aircraft. Ladies and gentlemen, please welcome Dr. Xiaoyu, our first speaker for today.
Good morning, everyone. Thank you for the introduction, and also like to thank you for this opportunity to speak at such a prestigious conference. My name is Xiaoyu. I'm currently a postdoc with CityU and also co-founder of CX Technology from Suzhou, China. Well, today I'm here to talk about hydrogen-powered UAVs, their integration, their control, and most importantly, their applications. And I shall begin with a brief introduction of the background. Namely, why do we need zero-carbon autonomous flight? Well, a low-altitude economy has become, well, somewhat of a hotspot, somewhat of a keyword in recent years. It refers to using the low-altitude space for aerial transportation, sensing, communication, and so on. Well, while we talk about low-altitude economy, we have to be reminded that the aviation sector already takes up a very considerable amount of our carbon emissions. Therefore, a lot of focus has been placed on zero carbon aviation, meaning climate neutral and sustainable solutions. And that leads us to sustainable aerial vehicles. How do we achieve long endurance, autonomous, and safe flight? And when we talk about sustainable aerial vehicles, we focus on its energy system, which is the heart of aerial vehicles. Well, traditionally, we have used internal combustion engines or aircraft engines to power our aerial vehicles. Well, more recently, on the DJI drones, for instance, that we see today, most of them are powered by lithium-ion batteries, which are great. They are great solutions. They are very dynamic. But however, they are limited by their low energy density, meaning that they suffer from short endurance. Well, the endurance of most of the battery-powered UAVs we see these days are, well, around 10 minutes to half an hour. And that's why we take our attention to hydrogen. As we all know, hydrogen has very high energy density. And by combining hydrogen fuel cells with an auxiliary battery, we can achieve endurance of up to 10 hours while having zero carbon emission. And therefore, as the energy for aerial vehicles move from traditional to sustainable solutions, we turn to hydrogen-powered aircraft for a long endurance and pollution-free flight. Well, to give a brief introduction on the history of hydrogen-powered aircraft. The first hydrogen-powered aircraft was developed, well, over 20 years ago by AeroVironment Corporation from US. But that was a very early prototype. It only allows an endurance of 15 minutes. Almost 10 years later, China's first hydrogen UAVs has been developed. And then another 10 years after that, back in 2022, well, in a collaboration between CityU and CX Tech, we have developed the first hydrogen drone that is fully autonomous, meaning that it can achieve autonomous flight, trajectory planning, collision avoidance, and so on. And then, in even more recently, just last year, Joby Corporation from the US developed a manned hydrogen-powered aerial vehicle. So the one you see on the bottom right here, this is powered by hydrogen fuel cells, and it has achieved a flight of over 800 kilometers, which is 3 times the endurance of its battery-powered counterpart. Now to go on to a little bit of details. What are the hydrogen aircrafts consist of? What is its topology? Well, it consists of 3 main systems. The first is the aircraft motor and rotor systems, because when we're talking about hydrogen aircrafts, we're also talking about electrified aircrafts. Therefore, it is powered by electric motor drives, motor controllers, and propellers. And down on the bottom left, we have a hydrogen and battery hybrid energy system. Well, to explain a little bit, why do we need a hybrid? Well, hydrogen fuel cells are great for powering drones and vehicles and so on. But however, they also have a relatively slow dynamic response. Whereas lithium-ion batteries have, well, famously very fast response. And therefore, we couple a lithium-ion battery, a small one, auxiliary one, with the fuel cell and combine them with a DC-DC converter through the DC bus for our energy system. And another interesting thing to note is that we also need a flight and energy controller unit for the aircraft, meaning that in addition to the autopilot, which handles the trajectory planning, the flight controller that handles the flight control, we also need a separate energy controller that controls the valves and the fans on our fuel cell, and also deals with power allocation, meaning that it needs to decide how much energy does the fuel cell and the battery output respectively. And therefore, we can conclude that as the hybrid energy system adds a level of complexity to the control of the UAV, and that control and management is one of the core challenges for autonomous flight. And now I shall move on to a little bit of our research on the safety control of hydrogen UAVs. Well, we all know we are very concerned about the safety of hydrogen and also the safety of UAVs. And also, recently there has been a lot of discussions on the safety of electrical vehicles, which has already been purchased by a large part of the public. And when we consider the safety control, actually a lot of parallels can be drawn between electric vehicles and hydrogen aircrafts. Although that I would argue that hydrogen aircrafts operate in much more complex environments. Firstly, because UAVs operate in low altitude space, it is operating in unstructured environments instead of the labeled traffic environments of EVs. And secondly, because most most hydrogen UAVs that we develop today are powered by hydrogen electric hybrids, this adds a layer of complexity to its control. And thirdly, as UAVs are propeller-driven, they operate in 3D instead of 2D space, meaning that the autonomy, safety, and efficiency are some of the main challenges towards the safety of hydrogen UAVs. So what enables the autonomous flight of UAVs? For hydrogen UAVs specifically, it is a combination of trajectory planning and power allocation. Well, trajectory planning refers to the trajectory generation according to our mission, our constraints, and our obstacles. Meaning that it needs to perform obstacle avoidance, which is particularly important in Hong Kong, which is such a developed urban area. And also needs to perform energy optimization. Because why do we use hydrogen UAVs? It's all about the endurance. It's all about the energy efficiency. And that leads us to power allocation, which can be defined as the efficiency optimization for the fuel cell and battery hybrid. As I mentioned before, why do we use a hybrid? It's because while fuel cells has a high energy density, it also has relatively slower response, whereas battery has lower energy density and capacity. It has a faster response. And therefore, the allocation is to create a synergy between the hybrid system to enhance energy efficiency and increase system lifetime. Well, I will not go into too much details on the mathematical terms, but just to give you a brief idea. So traditionally, we perform the trajectory planning and tracking and the energy management, the power allocation, entirely separately. That means the flight controller does not know any information coming from the energy controller and vice versa. So what we do here is propose an integrated solution that combines trajectory planning, tracking, and hydrogen consumption minimization into a co-optimization approach that takes into account the kinematic constraints, capability constraints, and so on. Well, with this co-optimization framework, we have achieved some results. Firstly is a coordinated control and management architecture that increases the range by 10% and prolongs system lifetime by over 20%. And secondly, as I mentioned before, the hydrogen drone we developed is the first drone that is hydrogen drone that is capable of fully autonomous flight, meaning autonomous planning, control, collision avoidance, and it can also land and take off entirely by its own. And thirdly, well, as I mentioned before, as safety is such a key topic for hydrogen UAVs, we also developed safety fault-tolerant flight control. As you can see on the video on the right, that it can safely land even when one of its propellers are entirely broken. Of course, this experiment is done on a smaller scale UAVs, as we don't want a 100 kilogram UAV to spin at this rate. But the idea has already been proven. I'm not going into too much details on the academics, but if you're interested, you can check out some of our selected publications. Well, just this year, we are also publishing a monograph on the safety control of hydrogen fuel cells. And we have also published a team standard, 20 标准, a group standard on the safe control of hydrogen UAVs. Well, now to move on, a topic that perhaps more of you are interested in is applications and prospects. What can hydrogen UAVs be used in? And what does a hydrogen aerial vehicle solution look like? Well, firstly, to answer, how large are the hydrogen UAVs? Well, we try to use a modular energy platform to cover all weight classes. What does this mean? It means that we begin with the 25 kilogram UAV that is powered by a 3 kilowatt air-cooled fuel cell pack. As we're talking about one single pack here, and it has a endurance of almost around 3 hours, fully loaded. That means it's carrying 6 kilograms of payload. But what do we do when we want a 100 kilogram UAV? We simply use 4 3 kilowatt fuel cells to create a multi-fuel cell system. And that allows us to carry a payload of over 40 kilograms. And talking about even a larger scale, what do we want to carry a payload of over 100 kilograms? We use 4 by 4 3 kilowatts fuel cells to generate a matrix. So why do we use this modular platform? It allows us to cover a very large range of weight classes while still using modular single fuel cells. And that also adds a level of redundancy, meaning that when we have 4 3 kilowatt fuel cells, even when one of them breaks down, it can still safely land because we have this level of redundancy. And that I believe that this idea is great for the safety of hydrogen UAVs. And also, it should be noted that you don't see DJI developing a battery-powered UAVs with the capability of 100 kilogram payload and over 1 hour of endurance. This is something that only can be done by hydrogen battery hybrid. It's because of the higher energy density. But of course, when we talk about using hydrogen UAVs, hydrogen doesn't just come from air. We need an integrated solution. So where does the hydrogen come from? Well, I'm sure that a lot of you here are more experts on the hydrogen production side than me, but generally we offer a number of solutions to some of our customers, either through electrolysis or ethanol-based hydrogen generation. And depending on the size of the UAVs we're using, we can either couple our UAVs with some of the hydrogen generation stations. These stations are entirely portable, by the way, or we can just simply deliver the hydrogen tanks to you for you to replace. But of course, when we want to use the hydrogen UAV, we also need to group the UAVs with an integrated solution. That meaning we need a online operation software, and we need a ground station. So the ground station knows where the UAV is and whether it's performing the desired mission at a certain moment. Whereas on the web, we want a management system to know whether all the UAVs across a certain area is operating as desired. And also, we also designed a series of terminals for the UAVs, as is shown in the next slide here. So depending on the size of the UAVs, what we want to deliver to the consumers is a series of airports, meaning that we have either hydrogen tanks or hydrogen refueling stations, and also battery charging stations, and also our spare parts inside these airports. And this further creates an integrated solution for hydrogen UAVs. And now to move on is applications in smart cities. Because Hong Kong is such a developed and urban area, well, most of our low altitude applications focuses on aerial logistics or aerial monitoring. In fact, just this year, I believe Hong Kong has published this low altitude application sandbox, a number of applications that covers healthcare, meaning the delivery of emergency medical supplies. And you should note that because our UAV is capable of carrying over 100 kilograms of load for over 1 hour. This doesn't just mean small loads like medicine or so on. We can actually carry large medical equipment via air. And also it can be used in environmental protection, meaning water and air sampling, and transportation, meaning traffic surveillance, because our UAVs is capable of hovering above a traffic intersection for over 3 hours. It is definitely more desirable for traffic surveillance. Because if you're using traditional battery-powered solutions, your UAV needs to come down and replace the battery every 30 minutes or so, which is not desirable when you want a long-term surveillance. In terms of agriculture, it has already been applied in Jiangsu for pest control, for spraying of pesticides. And for energy management, it can be used for a disaster assessment. And it has also used, we have also demoed a aerial firefighter drone also in Jiangsu, meaning that we can actually carry the water tank and the water spray on the UAV. Well, these are just it is in no way a comprehensive list of the applications of hydrogen UAVs. However, because I'm a researcher myself, we are also working on some perhaps more interesting, more cutting-edge applications for hydrogen UAVs. Firstly is hydrogen UAVs for Antarctic exploration. This is an ongoing project with the China Polar Research Institute. We are bringing this drone on the left to the Zhongshan station of the South Pole by the end of October this year. So one of the desirable features for hydrogen robotics in the Antarctic is that it has great heat-preserving properties. As some of you may know, that when fuel cells generate electricity, it also generates somewhat the equal amount of heat. And this is perhaps not desirable on a hot summer day like today. But when we are working in the South Pole, it is very desirable because we want to keep the entire system warm and running at its optimal temperature. And that makes it easy as we design a heat-preserving structure around the fuel cell and battery hybrid. It is actually, the heat can be used to maintain this energy system at its optimal temperature. And that is something that is very difficult to do on a purely battery-powered UAVs because batteries simply do not generate that much heat. The second is applications in satellites. Well, again, as some of you know, that NASA has been using fuel cells in its space stations and satellites as early as the 1970s. Well, however, as in recent years, Hong Kong has also has an upsurge in the research in aerospace engineering. So we're trying to bring compact hydrogen-based power solutions to some of our commercial satellites. This is also a ongoing project that we have a small commercial satellite that is scheduled to launch beginning of next year that carries one of our hydrogen fuel cell solutions that is customized for satellite applications. So because with satellites you need a much more compact solution, and you also need it to be up to the aerospace standards, meaning that it has to handle vibrations and large temperature variations, which is in fact more challenging than most of the fuel cell applications. Well, the third one is edge computing with hydrogen UAVs. Well, in the last slide, I talked about aerial logistics and aerial monitoring. Whereas these days we're talking about the AI age. Everyone is using large language models. But as you all know, the AI large language models are also very power consuming, sometimes even more consuming than the UAV itself. So therefore, the only solution, if you want to perform mobile edge computing on UAV platforms, we have to use a hydrogen-based solution because it simply carries 5-6 times more energy. And in this edge computing UAV we've seen here, this test flight is conducted just last month. We have brought an edge computing module that is capable of locally running DeepSeek and other large language models on board, and it can provide computing and communication services towards a wide area of agents. Well, finally, to give a brief conclusion, well, I believe that hydrogen aircrafts and hydrogen UAVs are one of the future solutions for long-endurance aviation. When we talk about long-endurance, heavy load, and zero carbon, I believe it is, in fact, one of the only solutions. And we are also working on evolution from the UAV to intelligent aerial robotics and for its applications in polar and aerospace. Well, some of our drones have won a gold award from the Asia exhibition, Innovation Inventions, and the gold award at the International Exhibition, Inventions Geneva, and has seen coverage from CCTV and Xinhua News. Well, finally, to give a brief introduction of our company, Suzhou CEX Tech. Well, actually, we do more than hydrogen UAVs. Actually, we have a business in 4 sections. The first is the shared hydrogen bikes. We have already deployed over 1,000 hydrogen bikes all over mainland China, in Beijing, in Jiangsu, in Suzhou, in Lianyungang, etc. And the second is, as I mentioned before, covering a wide range of hydrogen UAVs. And we also provide hydrogen-based solutions for power generation, meaning that we have an integrated solution for hydrogen production, storage, and fuel cell. And firstly, as I'm a researcher myself, well, a lot of the schools, both in Hong Kong and mainland these days, they're focusing on hydrogen education. So we are also helping universities like Beihang University and Harbin Institute of Technology to build their hydrogen education curriculum and their teaching aids. Thank you for your attention.
Thank you, Dr. Gu Xiaoyu, to give us a fruitful talk on